Alright, so let's go ahead look at I'm gonna go through. This is not a review since we have a little bit time, so I'm gonna go through the PowerPoint. Look at what is in the PowerPoint here. Alright, so we're gonna go through a section by section, and then next week we're gonna have a chapter 2 overall review. Alright, so for this one we have a little bit more time. Okay, so the chapter 2 here is the function and graph. Okay, all right, we also talk a little bit function in the chapter 1, right? But this will give you a little bit more detail, the basic function and the graph. Okay, all right, so one thing is for the function, I usually say a function like a machine, right? And you cannot throw the junk to the machine because it will break them, right? Just like you drive the car, you have an engine, and then you have to fill you have to fill the gas in order for for the car to run, right? But you cannot like fill in the wrong gas. Okay, so each function has a domain and range. All right, so a function is like a machine. Domain is your input, range is your output, right? And we're gonna need to be able to determine the relationship of the function, okay? And also determine an equation is a function or not, and then need to be able to evaluate it. And of course you need to graph the function, right? Identify the vertical line test and the horizontal line test for the function, and knowing how to identify the x-intercept and y-intercept from the graph. Okay, so that is pretty much the objective for this section. All right, so let's see what is function. Okay, a relation is any set of the ordered pair. Okay, the first set of the first component of the ordered pair is called the domain of the relation, or the relation is the function between the x and y, basically. All right, so domain is considered the input, range is considered the output. All right, so what is that? We usually using the function, right? Using the f of x represent a function. All right, and x is considered the input. Okay, and this input is the domain. All right, and y is the output. Okay, and the output here we also call it a range. All right, so and some of them book is called, this is the fourth set. Okay, fourth set, and the range is considered the second set. All right, whatever you want to call them. So we usually just call the input and output, domain and range. All right, so x is the input or the domain, y is the output or the range. So all the x value is considered a domain, all the y value is considered a range. Okay, so if you look at these ordered pairs, right, the domain will be all the x value. So where's the x value in here? Well, 0 is the x value, right? This is the x, this is the x, this is the x, this is the x. All right, so you have a 0, 1, 2, 3. Those are the x value, these are the x values, so that is the domain. Okay, and the y value is the second one, so this is a y value. All right, y value is the range. So we also call this is the input, this is the output. All right, similar to the domain and range. Okay, so those are the concept for the domain and range. And so a function is a correspondent from a first set called a domain, all right, to the second set called a range. Okay, and if each element in a domain corresponds to exactly one element in a range, that is considered a function. All right, so this one you have to now the concept start coming up. So the function is 1x can only have a 1y. 1x can only have 1y. Okay, one x can only have one y. So for example, if I have a 2 and then my y, if I have a 2 and 3, right? So 2, 3, 1 x, we have a 1 y. And I also have a 1 and 3. And some people say, oh, I have a 1 and I also corresponding to the same number 3. Is this a function? The answer would be yes, this is still a function, even they corresponding to the same value, but this is 1x. Okay, this 1x is only have a 1y, even they have the same y, but it's still 1x to have a 1y. So this is still considered a function. But if I have a 2 and 3 and let's see, 2 and 4, for example, if I have this kind of situation, so now I have a 2 to 3 and then I have a 2 to 4, right? So this is your x value, this is y value. So this one will be not a function. This is not a function. Okay, this case 1x has 1y, so this case is a function. All right, and 1x corresponding to the same y, but it's still only 1y. So this one is considered a function. This one you have a 1x and then you have a 2y's. Okay, look at it. 1y is 3, 1y is 4. So this case is not a function. All right. So we just need to know how to identify a function. So you have to understand the concept 1x can only have a 1y. All right. If this relationship satisfied, now is a function. Okay. So if you look at this one right here, 1, 2, 3, 4, 5, something like that, right? We can give it a little bit of graphing. 1 corresponding to 2, 3 corresponding to 4, and then 6 corresponding to 5. 8 is also corresponding to 5. Look at that. So this is still a function, right? Because even these two has the same 5, but it's also 1x only have a 1y. Okay. All right, function is an equation, right? So if we have like I said, if we have f of x equal to x plus 1, is this one a function or not? We can go ahead and give it a little bit graphing. All right, so this will be 0 and 1. When x is 0, y will be 1, right? So this is y equal to x plus 1, or f of x equal to x plus 1. You can use y or you can use f of x. They are the same thing. All right, so is this one a function? Well, actually the answer will be yes, this is a function, right? So how do I know I have a 1x corresponding to 1y? I can do a little bit of vertical line. So if I do a vertical line in here, I only pass 1 point. Vertical line anywhere on the graph, right? If I draw a vertical line anywhere on the graph and it's only passing 1 point, so this one will be 1x only corresponding to 1y. So this one will be a function. Okay, so sometimes we call this one is a vertical line test. All right, the VLT, vertical line test. Okay, when you drop a vertical anywhere and it's only passing 1 point, that is a function. Okay, so if we graph this one, actually this one, the graphing for this one will be a circle. Okay, if I graph x squared plus y squared equal to 1, this is a circle with origin with the center in the origin. Okay, and radius equal to 1. All right, the radius equal to 1. So this is a circle function. And look at this one right here. If I draw a vertical line, right? Look at it. If I draw a vertical line, how many points do I pass? How many points?
1.
More than 1, right? Look at it. If I draw a vertical line here, I pass 1 point below here, I pass 1 point in here. If I draw a vertical line in here, I have a 1 point right here, I cross another point right here. So this is called 1x value, you have a 2y. Okay, so this is not a function, all right, because it didn't pass the vertical line test. When I drop a vertical line, it passed 2 points. Okay, if you drop anywhere, as long as one line past 2 points, is disqualified. All right, so this one you drop several lines, you all pass 2 points. Okay. All right, so those are called a vertical line test. Okay, for the graphing. We're using f of x to represent y because it's much easier to use this called a function notation. Okay, the function notation here, like I said, if I want to have a y equal to x plus 1, right? So instead of write down f of the y, write down the y, I can just write down y is a function of x, and then fy is equal to f of x and equal to x plus 1. Or you can just write down f of x equal to x plus 1. So when you write down this way, it's very easy. I can just say, let's calculate f of the 0. So what does this one mean in here? So in math, sometimes we say math is kind of another foreign language, something like that, right? It has its own symbol, syntax. So this one is considered, say, we want to find a y. So basically, if I write down f of the 0, so that means we want to find a y when x equal to 0. So the inside here is the x. Okay, so that means I want to find the y value when x equal to 0. So y is equal to f of the 0. So how do I calculate this one? I will replace this x by the parenthesis, because look at that, this is f of x. So whatever I have an x, I replace by here. So this one will be 0 and then plus 1, right? You still have to plus 1 here. And then this equal to 1. So what does this mean in here? This means x is 0, y is 1. Look at it. So I don't have to write down the whole sentence, say, please find a y when x is equal to 0. Right, so I don't have to write down the whole sentence. We just write down f of the 0. Find the f of the 0. Okay, so what does that mean? This means this whole thing, right? This means you have to find a y when x equal to 0. Okay, and the point here will be 0, 1. So when x is 0, y is equal to 1. Or we can just write down f of the 0 equal to 1. That will be this point here. All right. And then I can also write down f of the 2, right? So what does that mean in here? That means I want to find the y value when x equal to 2. So how much is my f of the 2? Well, replace x by 2. So this will be 2 plus 1 or equal to 3. All right. So once you have this function notation, it's very easy to express the math in here. Any questions? Anyone has any questions? Okay, so look at this one right here. All right, we're gonna go ahead and give this one a quick calculation. How do we calculate this one? So this one is we want to find a y value when x is equal to -5. Okay, and what is the f expression? This is your f expression. F of x is equal to x squared minus 2x plus 7, right? So how do I evaluate this one? Well, I can just write down my f of -5. Remember, replace x by here. This is replace x by -5. So this is gonna be -5 squared. Both -5 is the x value, so you have to have a parenthesis, right? And then minus 2 times the x, and then x is -5 plus 7. All right, so that is how you calculate. And then this negative also have a square, so negative square will be positive. So this is positive 25, right? And then negative times negative is positive. So 2 times 5 is 10, and then plus 7. So you're gonna have a 35 plus 7, or just equal to 42. So that means the f of the -5 is equal to 42, right? So that means if I write down in an ordered pair, this will be -5 or 42. So this is the x value, this is the y value in here, the point. All right. So that is how you calculate this type of the function notation, okay, calculate. And if I want to find f of the 0, okay, so how do I find my f of the 0? F of 0, that means when x equal to 0, how much is y value? So this is called the y-intercept, right? When x is equal to 0, find the y value, that's the y-intercept. And this one, it will be 0 squared minus 2 times 0 plus 7, right? Replace x by 0. So 0 squared is 0, 2 times 0 is 0, so this will be just equal to 7. So I can write down the 0 common 7, right? Because when x is 0, y gonna be 7. Alright, so that is how you use this type of function notation to do the calculation. Okay, we can graph the function, with this order pair, right? Now I can graph this one. I have a 0 and 1, right? And then I also have a 2 and 3, right? Something like that. So I can graph, I can graph all the function, right? Same thing as this one. Or the better one, I can put in a calculator and graph them, right? So you can do either way. We can do the manually, or we can do the graphing calculator, which is the one I like. Using the graphing calculator, even easier. Alright, so before you use the graphing calculator, you also have to know a little bit character, right? So in case if you input it wrong, at least your graph is not the correct one, right? So this is the highest power is 2, so it's called quadratic. So this one will be a parabola, okay? A parabola, and then the coefficient of this square, x squared, is 1. 1 is a positive number, so this is gonna be facing up. Alright, so at least this graph we're gonna look at something like that. Okay, alright, so we can go to y equal to, right? And then we input the x squared, so this is x squared. Alright, let's see, where's the x squared? X squared minus 2x plus 7. Okay, so minus is right here, minus 2x, alright, plus 7. Okay, alright, we hit enter and then we graph. Alright, so this is your graph in here, right? So you can see like we calculate when x equal to 0, y is 7, right? And we also calculate when x is negative 5, or y gonna be 42. And you can come to second graph, will be the table, right? So look at this one right here. When x is 0, y it is 7, right? And when x is negative 5, y is 42. So that is the 2 points we calculate. Okay, we just calculate these 2 points in here. 0 and 7, negative 5. Alright, 0 and 7, right? So we have a 0 and 7, and then we have a x equal to negative 5, y equal to 42. Alright, so this will be a quick and easy way if you really don't want to calculate by hand, right? But I still suggest that people do that by hand a few times, just to get familiar with the process. Alright, so this is a parabola facing up in here. Okay, any questions? If you have a question, you can always jump in and ask, okay? Alright, so you can graph the function in the order pair, right? So how do you graph this one right here? If I want to graph this one by hand, alright? So that, like I said, I want to graph this one by hand, right? And then this is x is 0, y is 7, so you can have a 2, 4, 6, 8, right? This is 2, 4, 6, 8, and then 7 will be right here. Alright, so that's a point, right? And then when x is equal to negative 5, so that's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, right? So negative 5 right here. This will be negative, this will be when x is negative 5, this is positive 42, so that'll be somewhere right here, right? Pretty up, basically. So and then you make it a graphing, You probably need a few more points in order to curve this one, okay? So that is you do that manually. all right, or you can use the calculator as a reference in here. Alright, so graphing this function, right? And then if I have a y equal to 2x and then another y is 2x minus 3, what kind of relationship do we have for this graph? Alright, one thing I will know is these two graphs actually look the same, except this one is moving down for 3 units. Alright, so if I make the graphing in here, okay, so y equal to 2x. This will be f of x equal to 2x. Okay, all right. And then this one 1, 2, 3, negative 3. Okay, so this one will be very similar, parallel to this one, but move down for 3 units. Okay, so let's see, make it a graph. So this one will be g of x equal to 2x minus 3. All right. And if we write down this y equal to mx plus b form, right, which these two are in a slope intercept format, so your m here, m1 here is 2, your m2 here is also 2. So these two lines parallel, the two lines parallel because the slope is the same. Okay, when they have a same slope, two lines will be parallel. All right. We can also put this one in a calculator, graph them, all right? Okay, so I have a y equal to 2x, right? So you can see this is how y equal to 2x, look at that, right? And then we're gonna graph another one is 2x minus 3. All right, so you can see, yeah, these two lines are parallel, okay? What does parallel mean? That means they never intersect. Okay, this is just keep going on and on. They never intersect each other, so that's parallel. All right. Okay, so we can see this one. You can do a little bit calculation. Yeah, you can pull the when x is 0, y is also 0, right? This one when x is 0, y gonna be negative 3. So you can do a little bit point and do the calculation, and then you can drop them. Or you can go to second graph. Second graph is table, right? So now you can see, look at it, like you see, oh, when x is 0, the y1 gonna be 0, y2 gonna be negative 3, right? So you can pick up a few points from here as well. Okay, so the blue one, you can see the blue one corresponding to the blue one, right? That's y1, and the red one is y2. Okay, so now you can see this is y1 function, this is your y2 function. Okay. All right, so that is called a parallel line, right? What's a vertical line test for the function? As I mentioned earlier, if any vertical intersect in a graph in more than one point, now the graph does not define as a function. Okay, so that's called a vertical line test. This is not a function if you have a connection more than one point. All right, so look at this one right here. This is a circle we talked earlier, right? So this got a 1 point intersection here. You cross another point right here. So this is not a function. Okay, the second one is not a function because it crossed 2 points. This one is a function because even you drop the line right here, right? Drop the line anyway, only cross 1 point. Even I drop a line right here, it's also only cross 1 point. So this one is a function, but not that one. Okay, so that is considered a vertical line test in here. All right, analyze the graph of the function. Okay, so yeah, you can using the graph to do a little bit analyzing. So find the f of the 5. What does f of the 5 mean? That means you want to find the x value equal to 5 and then trying to see how much is the y value, right? So if I make this one much bigger, all right, so now we can see, well, that is the x value in here. Look at that, this is my x value 5 right here, right? So we're gonna go to trace this one in here, and then this y will be somewhere right here, right? Somewhere right here. All right, so that means when x equal to 5, okay, time after the inflection here and then the unit is in here. So after 5 years, this one is the average T cell count, per milliliter of blood, okay, per milliliter of the blood in here. So that means after 5 years, the average T cell count will be 400, right? 400 milliliter in here. Okay, so that is how you do this kind of questions. So yeah, you can make the graph a little bit bigger, all right, and then you can see that a little bit better that way. All right, so that is how you do this type of question. Okay, any questions? I'm sure like on the MindLab method, you can also enlarge the graph, right? They usually have a little bit of something like that. They usually have a little bit, this is something like the title, the legend right there. And you can click that and you can enlarge the whole graph, okay? So make it a little bit more readable. All right, to find the domain of the function, okay, domain usually is all the input from the x, right? And the range is the output from the y, okay? So that is this one right here. So if I want to identify the domain in this one, okay, so I have this kind of a segment in here, right? So this segment, when I click this, it kind of misaligned. All right, so where's my x value? X is, look at it from this point to this point, right? So this point will be -2 up to here. And you can see this one should be, this is -2, this is 2. So this one origin right here, and each Greek here will be 1 unit, okay? So you're gonna have a x is gonna be from -2 to 1, right? And this is a solid dot on both sides. So solid dot, that means including the endpoint. Okay, and where's my y value? My y value, okay, I'm still want to make this a little bit bigger. All right, and if you look at this one right here, this is my y value. Y is vertical one. Okay, so this point when x is -2, y will be 0, right? Y is on the x, this is x-axis, y will be 0. So the minimum value for the y is 0. And this one is the maximum value for the y, okay? And how much is the y? Well, you have a 4 in here, this one is 0. So this unit here for the y will be 3, okay? So my y value here will be from 0 to 3, all right? And my domain x value will be from -2 to +1 in here, all right? So that is how you do the graphing if you want to do the x and y in here. Questions? All right, so this one is a solid dot, one is what? One is a circle, okay? So what does a circle mean? Circle means not include, okay? So if you have a circle, if you have this circle, that means not include the endpoint, not include the endpoint, or the beginning point, whatever. All right, so this one, that means it's gonna very close to this one. X is gonna be very close to -2, but it's never going to be -2. So that's why we using the parenthesis for the open point. And then this x will be 1 right here. So 1 will be a solid dot, will be a bracket because it's a solid dot. Okay, solid dot means include this point. All right, so similar with the y is gonna be from here, right? So this is y will be from -1 all the way to 2, okay, all the way to 2. And same thing, this doesn't include 2, so this one should be this actually is wrong. The range for the y here should be from -1 to 2, and 2 should be the parenthesis because it didn't have an equal sign here. All right, y is greater than or equal to 1, but less than 2. All right, so 2 should be a parenthesis. This one -2 is parenthesis, okay, and 1 is bracket because it doesn't include x equal to 1 here. All right, any questions? Okay, so that is the one we see the domain and range from the graphing. Okay. All right, we're gonna look at the x and y intercept and how do we find them, right? So if we want to find the x-intercept, you're looking at the graph or looking at the point that cross the x-axis. All right. So for example, if I have this one right here, right, this is y equal to maybe y equal to x plus 1. All right. If I have this straight line y equal to x plus 1, okay, so where's my x-intercept? My x-intercept will be graph passing the x-axis in this point. Point A is the point, the x-intercept point, right? And how much is this one? Well, if I have an x-intercept, my y must be 0. So this will be x and 0. So if I put a y equal to 0 in, I have this is x plus 1. So x should be negative 1. So this one should be negative 1 and 0 for the A. Okay, so that's the y, that's the x-intercept. This is the x-intercept. All right, and this point is considered a y-intercept. Okay, y-intercept x will be 0. All right, so we're gonna have a y equal to 0 plus 1 or just 1. So this one actually will be 0 and 1. All right, so that's your x and y intercept in here. Okay, look at this graph. Do we have an x and y intercept? The answer is yes, right? This is reading the graph, okay? So this x-intercept, it didn't ask you to write the order pair. It only just want you to write down the x value in here, okay? I know sometimes people do the chapter 1 test already and then they write down the order pair and they get counted it wrong, all right? So sometimes you just have to read the question requirement very, very carefully, all right? This one, it didn't ask you to write the order pair. It only need to write down the x value and using comment in here, right? So this one be negative 3, negative 2, and then a positive 2. Usually you write down in an ascending order. So from the left to right, usually write down in an ascending order, okay? So instead of write down the 2 and a negative 1 and negative 3, I write down the smaller number in the front, large number at the end. All right, and y-intercept, this is only one y-intercept, right? If you write down the order pair, x will be 0, y will be negative 6. But this one, again, it didn't ask you to write the order pair. It just only write down the y value for the y-intercept. So it will be just negative 6. All right. Any question? Guess what? This is 2.1. This is the one section already, okay? But one section we learn 3 concepts, or actually 4 concepts, very important, right? We learn what is domain, what is a function, what is the output, or what is a range. Okay, so domain, range, function. All right, those 3 concepts, right? In order to qualify to be a function, what do you need to have? You only want to have a one x value, can only have a one y value. That will consider a function. If you look at the graph, I look at the vertical line test. Okay, if I drop a vertical line anywhere, it only pass 1 point. This is a function. Drop anywhere, it only pass 1 point. So yes, this is a cubic one. This is a function. Okay, the domain x. This is looks like an all real number for the x, same thing as for the y. All right, so that's the domain, range, function. Okay, and then we also have a 2 small one. What is x-intercept? What is y-intercept? All right, any questions? Okay, we're gonna go ahead look at what is on the section 2.2. All right, so we just finished 2.1. We will continue to the 2.2, which is similar to the first section, but a little bit more, right? We're gonna more on function and their graph. Okay, so this one, what is more about a function? We're gonna identify the interval to see which interval the function is increasing or decreasing or is constant, right? And we also need to be able to identify the relative minimum or maximum and to see if a graph is symmetry, okay? And then identify the even or odd function, all right? And understand what is a piecewise function, okay? So that is just a little bit more concept in here, all right? So what is the increasing and decreasing function? Let's look at the graph in here, all right? And then we're gonna talk about the increasing. So from left to right, x is increasing, basically. All right, from left to right, okay? Left to right, x is increasing. So from left to right, x2 is greater than x1, right? So because x2 is on the right-hand side of the x1. So x2 is greater than x1, and I have a corresponding to the y, so this is y1 or equal to f of the x1, right? And then this is y2 equal to f of the x2. So when we have a graph from left to right, x is increasing because x2 is greater than x1. Y is y2 is also greater than y1. Look at that, y2 is on the top of the y1. So when x is increasing, y is also increasing. This is called an increasing function. All right, this is called an increasing function. Okay. On the other hand, in here, look at that. This is decreasing. You can see this is increasing. This one is decreasing. So from left to right, x is always increasing. Okay, x is always increasing. That means x2 is greater than x1. All right, my y2 here actually is less than y1. Okay, so when x is increasing, y actually is decreasing. All right, so this one is called a decreasing function. Okay, decreasing function in here. All right, because when x is increasing, y is going down, right? And this one, when x is increasing from x1 to x2 is greater than x1, right? So when x is increasing, what happens with the y? If I have this one is y1 and then this one is y2, okay? So my y1 actually equal to y2. All right, so this situation is considered a constant. All right, when x is increasing, y did not change, so that's a constant. Okay, all right, so when you have this kind of constant, slope will be 0 because your y2 minus y1 is the same, so it's 0, but your x2 minus x1 is not 0, so you have a 0 divided by a non-zero, and that's okay, right? So that's why this horizontal piece, your slope will be 0. All right, so we're gonna need to be able to look at the increasing and the decreasing interval, okay? If you look at this one right here, this is kind of like a turning point, right? A little bit turning point in here. But basically from left to right, before the turning point, before the -1 from left to right, x, y actually is increasing. Okay, from left to right, all the way from here, -infinity to -1, y is always increasing. So this one is considered increasing function. Okay, and then if you look at the middle part from -1 to 1, y actually is decreasing. Okay, and then after 1 in here, y is increasing again. Look at that, y is increasing again. In this case. All right, so that is how you identify the increasing or decreasing function. Any questions? Alright, so what is the relative minimum? We know the minimum or maximum, right? Minimum is the lowest point, maximum is the highest point. Okay, this is the highest point. Minimum is the lowest point. Alright, so this can be maximum, right? But this one, if we have this arrow, what does this arrow mean? This arrow, that means going up and up forever. This is keep going up. Okay, so we cannot really say this one is the highest point. But if I only compare to my left and right, I'm in the highest point. So this is called a relative maximum. Relative, sometimes we also call it is a local maximum. Okay, so what does local maximum mean? That means you can have a several city champion, right? Local maximum, you can have a multiple, you can have a more than one. All right, so let me give you another graph. All right, so if I have this graph, okay, what happened in here? So I have this one right here, this one right here. They are all called relative. These are all called a relative maximum. Okay, because compared to my immediate left and right, I'm on the tallest one. Compared to my immediate left and right, I'm on the tallest one. So that is, both are called a relative maximum. So the relative, when you see the relative here, that means you can have a lot, or you can have a more than one, right? You can have more than one relative maximum. So that means you can have a multiple city champion instead of Texas, right? Because there are a lot of cities instead of Texas. Okay, so you can have a several relative maximum. Okay, and same thing, you can also have a several relative minimum. Okay, so look at this one right here. This one is my lowest point on the left and right. This one is also on my lower point compared to my immediately left and right. Alright, so this is called relative minimum. Okay, same thing, relative minimum can have a more than one. Okay, so sometimes we also using local this word. Alright, relative minimum means local. Alright, any questions? Okay, so look at this cubic function in here. We have this one, it considered a lower point, right? So this is relative minimum. Alright, this one is a little bit higher on the left and right, so this is called a relative maximum. Okay, if you don't include a relative in here, that will be the absolute or the real maximum, right? This one, the real maximum here will be going to infinity. This one will be negative infinity, basically. Alright. Okay, so we also need to be able to look at the symmetry about a function, right? How do you test for the symmetry? Well, you're gonna replace x with negative x. If you replace x with negative x and you still come out the same, basically that is considered a symmetry around the y-axis. Okay, so look at this one right here. Look at this graph. Alright, so how does this graph look like? If I have y equal to x squared minus 1, y equal to x squared graph will be the vertex is in the origin, right? And then minus 1, that means you move down for 1 unit. Okay, so your vertex will be right here. Alright, so that is y equal to x squared minus 1. Okay, you can see if you put this one in the calculator, see a little bit better, you can see this one is a symmetry around the y-axis. Alright, so what does the symmetry mean? That means if I fold this graph around the y-axis, my left side gonna be overlap to my right side, like a P gonna become in a Q position, and then these two distance to the y-axis will be the same. Okay, so that is considered a symmetry. And we can always look at the graph. Okay, so this one is x squared minus 1. Alright, so you can see this one right here, looks like this graph. If I fold this graph along the y-axis, my left-hand side gonna overlap the right-hand side. So this one is considered symmetric with the y-axis. And when you have a graph with symmetry with y-axis, is considered symmetry along the y-axis. Okay, how do you use the algebra to express that? The algebra here will be f of negative x is equal to f of x. Alright, so that means if I replace the x by negative x, look at it, I replace this x by negative x, and negative square is still positive. So if I have a f of negative x, right, so this will be negative x squared minus 1, and negative square is positive, right? So my f of negative x actually is equal to x squared minus 1. And this one actually is equal to f of x. Look at it. This y is my f of x. Alright. So that means if you replace x by negative x in, and you still come out with the same function, that is symmetry. That is an even function. Okay? So this one will be an even function. Or the even function is symmetric with the y-axis. Alright, so that's the even function. The R function, so what's the R function? R function actually is, look at it, the even function is symmetric with the y-axis. The R function is symmetric with respect of the origin. Okay, and then if I want to do the algebra way, this is from the graphing way. Okay, you can see that from the graph is the symmetry or not. Alright, and this one is the algebra way. Okay, this is the algebra way. So if I don't graph, how do I know this function is an even or odd? I can just plug this one in to see what happens. For example, if I have a f of x equal to x cubed, is this one an even or odd function? Well, we can calculate both, right? So first, if I have a negative f of negative x, trying to see if I can come out if equal to f of x. If it does, this will be even, right? So we're gonna plug this one, replace the x by negative x in, and then we know the negative cube is still negative, so this will be not equal to f of x, right? Because my f of x is positive, and if I have an f of the negative x, I come out with negative x cubed. So this is not equal, so that means this is not even. Alright, and we're gonna go to calculate negative f of x. So what's my negative f of x? My f of x is x cubed. Alright, so these two actually is equal, right? So that means I prove f of negative x actually equal to negative f of x. These two calculation is a little bit different, right? The first one here, you have to replace x by negative x. The second one is you using the negative multiply the entire function of f of x. Alright, so these two come up is the same. That means they're symmetric with the origin. Alright. Okay, so this one's symmetric with the origin, right? So if I graph x to the 3 power, okay, so you can see, yeah, if how do I know its graph is symmetric with the origin? If I drop a random point, connect to the origin and extend to the same point, you can find a corresponding point right here. That's considered symmetric with the origin. Okay. Alright, so let's see, is this an even or odd or none of them? Okay. Alright, so first, if we want to be an even function, we have to prove f of negative x equal to f of x. In order to prove an R function, we have to know the definition. These two should be equal. Okay, So now we can go to proof them. We can find the h of negative x. This is going to be negative x to the 5 power plus 1, right? And the negative to the r power is still negative. Alright, so basically this one is not equal to h of x, because my h of x, the first term should be positive, but my h of negative x, the first term is negative. So these two are not equal, so that means this is not an even. Okay, it's not an even function. Alright, is this a r function? Well, we have to calculate the negative h of x. So using negative times the entire h of x. Okay, and then if I distribute, get rid of parentheses. Okay, get rid of parentheses. So this is my negative h of x. My h of negative x is this one. Alright, are these two equal? Not quite. You have one is plus 1, one is minus 1. So that means this h of negative x is not equal to negative h of x. So this is not r either. Alright, so that means this function is not symmetric with the y-axis. The function graph is not symmetric with the origin either. So we call this one is neither r nor even. Okay. Alright, so if you go to look at this one, because this whole thing kind of move up for 1 unit. Alright, so this graph will be look at something like that. H of x equal to x to the 5 plus 1. So this with this one skew everything. Alright, so this point is not symmetric with the origin anymore that way. Okay, if we don't have this one right here, this will be a r function. Alright, but with this one right here, it moved up for 1 unit, so this is not an r function anymore. Okay. Alright, so another function here is considered a piecewise. Okay, sometimes people get a little bit confused with piecewise. So piecewise, basically you have 2 pieces of the function in one graph, right? So if I go to graph this one, we can pick a, we can pick a point, right? So this actually this f of x or y equal to 3 is a constant number. So if I make a graph then, alright, and we have a -1, 0, -1. So look at that. I'm gonna put a little bit separate this whole thing into 2 parts. Alright, separate this coordinate into 2 parts. And then when x is less than -1, less than or equal to -1, this will be 3. So 1, 2, 3. Alright, and this one should be a solid point because it has an equal sign, right? And then less than, so it's going to the left. Alright, so that is my f of x equal to 3. And x is less than or equal to -1. You cannot cross this one. You cannot cross the whole thing in here because this stop at x equal to -1, right? And then the second piece is y equal to x minus 2. X should be greater than 1, no, greater than -1, right? And then we can go to calculate this one. So 0 is greater than -1. So when x is 0, y will be -2, right? When x is 0, y will be -2. So we have a -1, -2 right here. So this is the point, right? And when x is equal to 1, when x is equal to 1, y is equal to -1. So it should be right here. Alright, but we also have to connect to this point. This point when x is equal to -1. So if we calculate x equal to -1 right here, this will be -3. So this point, since we don't have an equal sign right here, so you have to use a circle. So this is exclude this point. Alright, so -1 when x is -1, this is -3 right here. So this is circle point. And then you connect all this together. So that is f of x equal to x minus 2 when x is greater than -1. Alright, so you cannot move this one to the left hand side because x must be greater than -1. Same thing, this one have to stop right here. So that is called a piecewise, piece by pieces together. Questions? Okay, that is the graph in here. That's the graph. Sometimes people ask, is it possible I can use the calculator graph this one? The answer is yes, but a little bit tricky. Okay, I can show you how to graph in a calculator. All right, but this one is graphing by hand. Okay, if I graph in a calculator, I also have to set up the condition. If I don't, questions? All right, please unmute yourself until you want to talk, okay? So that way we can keep everyone in the same pace. All right, if you have any question, you can ask anytime, but mute today until you want to talk. All right, so we have a y equal to 3, right? So this is y equal to 3. If I graph this one without setting the condition, this is gonna be graphed from all the way from left to right, okay? Same thing as this one right here. I have a y2 equal to x minus 2, right? X minus 2. And then if I graph them, same thing, this will be graphing from everywhere, right? And that is the regular graph, right? But if I have to go to set up the condition, say, oh no, the first one right here, x should be less than or equal to -1, right? So I will need to go to this one right here, set up the condition. So how do I set up the condition? I was using the divide by sign, and then using the parenthesis, and then set up the x. So x should be less than or equal to -1, all right? And where do you find the less than or equal to? You have to go to the test. So second math is the test. All right, so this less than or equal to in here, number 6. Hit enter. And then less than or equal to -1 right here. So once I input this condition with this one and then I graph them, it stopped, right? Look at that, it stopped on x equal to -1. It stopped right here. It didn't go through this whole thing anymore, okay? And then same thing, the second one, I can set up the condition. All right, so how do I set up the graphing condition? Using the divide by sign, and then parenthesis, set up your x value. X must be greater than -1. So go to second math is test, greater than, so using number 3, greater than, okay? X will be greater than -1, that's -1. All right, close your parenthesis, okay? And then you graph them. All right, so look at this one right here. Now I have a piecewise I need, right? So this left hand side is x less than or equal to -1. This is x greater than -1. If you go to the table in here, you're gonna see this is all error. For this one is error. Why this one is error in here? Because you know, we graph for the y2, right? For the y2, this y2 x should be, you know, why this one has an error in here? Because it's undefined for x is you know, on the left hand side right here. This is only the red one only defined when x is greater than -1. Okay, same thing for the blue one. When x on the right hand side, this x will be undefined, right? So if you go to look at the blue one right here, after the -1, this will be all error. Okay, so that is considered the piecewise in here. All right, so you can do that by hand, but I also showing you how to do that in a calculator. Okay, any questions? All right, so piecewise, usually sometimes people have a little bit challenging to do the piecewise, okay? So, this is how you do the piecewise. You just have to graph 2 pieces in one equation, in one graph, you know, two functions in one graph, okay? Alright, last set for this one here is using the difference quotient. How do you calculate this expression? Alright, calculate this expression is a little bit okay, I'm gonna just giving you a little bit easy one to calculate. So how do I calculate x f of x equal to x plus 5? How to, this one actually is the slope expression, okay? The difference of the quotient. Look at that, the m here, we usually using y2 minus y1 over x2 minus x1, right? And this is trying to calculate, this is not the linear, okay? And then if I have this one is x, and then I increase a little bit, this one increase, this one is h. I have an x2 right here, right? So this one will be f of x. All right, and then this one right here is f of x plus h, or f of x2. All right, so basically, you know, if I using this function can only calculate a straight line, a linear. All right, use this function can calculate any graph. All right, so for those of you, if you want to continue to the calculus, this will be a really important function. But for those of you did not want to go through the calculus, you know, you can just using the linear. M is y2 minus y1 over x2 minus x1. That's why I only talk the linear in here. Okay. All right. So how do I calculate this one by the expression? You want to separate into 3 steps. Step 1, find the f of x plus h. Okay. So that means this x can be replaced anything by the parentheses. Since my parenthesis here is x plus h, so this will be x plus h plus 5. I'm using this one as an example. All right, so that's my step 1. My step 2, you calculate the numerator, calculate f of x plus h minus f of x, right? So f of x, this is the first one right here. This is the first one. This is x plus h plus 5 minus f of x. This is my f of x. So f of x is x plus 5. All right. And then we get rid of all the parentheses. This should be minus 5. This cancel out. This cancel out. So this will be equal to h. All right. So now I have this whole thing. I have a numerator is h over h, right? My numerator, this whole thing calculated is h. And then I divide it by h. So this is equal to 1. All right, so we know this f of x is equal to mx plus b, right? So m here is 1, m here is 1, so we know this one is 1. All right, so this basically, you know, kind of proving how to use this function notation to calculate the slope. Okay, so that is how you use this kind of notation to find the slope in here. Okay, any questions? Alright, so that is basically our section 2.2 already.